managers had open a business, do like some of the stuff that you do today, close out the business, take all that and put it in a digital kind of like checklist, so that they can hand it to the 14-year-old employee and they can properly open the restaurant or close out the restaurant. Do some cool stuff like you have a checklist item that you like scan a QR code. So like if it's like a deep clean or whatever, QR code on the back of the fridge, they have to actually move the fridge to access the QR code and so at the very least you know they moved the fridge, right? And so they like it. Right. So we're really big in restaurants and like things like
yeah, I'm the first week.
safety protocols.
So you've been there 2 months.
Got their receipt. And we're there to make sure they get right.
Before that, maybe startup doing the same thing. Yeah, so it was actually spun out of it.
So we already do that. So we've got a sensors product, and we haven't gotten into like door sensors and whatnot. The bigger use cases are sensors. Wow. Because we're in a bunch of restaurants, right? And so a restaurant needs to make sure like you're in a nice
Finding your own reason. We found a buyer.
That's great.
But yeah, I've done that thing. Back then, that's basically distributed storage. Got a full stack job, relatively small. Making the new one. Wow. It's like $1 million. I'm not even kidding. They just rendered funeral pictures. It's really cool.
Not somewhere.
But they offer the video for the family. They sell to the funeral home for years. The people say, hey, sorry for your loss. Let's make a video for your service, right? Yeah, so then they get them links from our software and pictures. The funeral home turns it around in like 5 minutes. They don't spend any time and they got this good video. So they love us and they mark it up as content.
It's insane. Yeah, but
Sorry for your loss.
yeah. Let me show you this casket.
I went to a trade show.
Yeah.
And there was like first running. Model of first. Tombstones. New tombstone designs. Portrait printers.
Oh my God.
It's like literally everything you would expect from everything there.
Didn't even know.
We were being sponsored, they gave us all the There's a market for everything.
Oh yeah. I mean, someone's got to do it.
Not from working at Jolt, but just networking events and different things. Both like random
They're the business that.
so it's a big random center thing. So, anyways, I had a long conversation on that, which isn't related to like starting companies or anything at all. Back in college, I did some like pitch competitions like that. Back in the day.
Yeah. I am so
It didn't go anywhere. You actually did. So, I classed right? I wanted to make the party guide, like digitize that process.
No, it's not related. It's completely related. It is the
They employ 150 people literally to just refactor transcript faxes, transfer the information from doctor's offices, and they're legally required when the information belongs on a glass prescription or contact prescription, like this is it's like totally better than the hard part is doctor's offices and all those third-party places.
What are the odds that you
they don't really belong. And
it's so strange.
it's not.
That's why I went back to
where anyone who's like necessarily change one boring problem per se. What contacts what I mean would be into it because it would make like their whole process more efficient. Right? They give like that like and doctor's offices like they're more concerned about like prescriptions actually expire that type of thing.
a lot of the repairs.
Yes.
Like big companies
Basically,
own
what pulled it up was
data, they're mining it for your information to sell you assets.
we start to integrate with
Our platforms and ground up.
when I first went to the doctor's office, they all said it was like
Your data, even if we want to take your license,
and they all say yes.
we're centralized.
They were saying yes, we don't.
Any of those
Hey,
data.
it really don't make sense. They were saying yes because nothing in doctor world for SaaS costs $2. Like doctor's office SaaS costs like $450 $500 a month. So
Yeah, so
they're basically for them really easy to be like talk to someone who's interviewing how to make this work or whatever. It was really easy for them to say yes to the month because that's super cheap. But then they did math on it and it was like even though it was super cheap, they were like, well, actually it's like $5 per transaction. And right now my employees that I pay $15 an hour.
It was next week I would tell you
Processing.
and still not quite.
It's cheap and expensive. And then the APIs all like straight up and
Yeah, they use it to utility.
From that experience, for at that time I had data science. I was having an academic degree, and I was on the business side. And so basically, I still think there's a need, but the need is more for like
You can think of this system a lot like this
operation. And that's actually what I started
longer term vision being like
that's to be operations manager.
they'll be used offering,
But rather than being like
so you could
like
stream video, yeah, like files that you don't need yet.
more restaurants that are
That's 1 megabyte file, breaking that into 80 pieces. And all around
Yeah,
that doesn't
yeah,
really
yeah.
make sense.
Like-
So those are directly on the satellite.
I do
We were exploring all of the video companies.
one of the founders of Get Mountain.
Yeah.
I think it's an angel.
Yeah.
But anyways, so he gave me this and then from the mouse
Basically, we were doing
I understood.
So guys, I just want to thank Randy Harrison for coming out. He works for Blockdaemon and is local to the area. Really grateful that you could come out, Randy. And he's going to be talking about some interesting tools they use for orchestrating blockchain. Before he gets started, I just wanted to share, I also co-founded a company called Blockscale that was acquired by Coinbase where he used to work. And so he's met my brother. My brother and I co-founded this company. And one of the reasons we did it was because we noticed that a lot of blockchain engineers were building blockchain clients and other tools without thinking about the implications of deploying their tools in the cloud. And in many cases, their tools didn't scale very well. They weren't built with kind of like 12-factor apps in mind. In some ways, blockchain almost is antithetical to the idea of creating large scalable services in the cloud because of the fact that blockchain is opting for this like utopian version of full decentralization, right? But sometimes when you're actually trying to get a blockchain application to work in practice, you have a lot of challenges with dealing with the current limitations of the tooling and still getting it to function, especially as the blockchain gets bigger and you have terabytes of blockchain state that you need to store and no individual laptop, as much as Vitalik Buterin would like it to be otherwise, can handle that kind of load. So, and I just pick on him because he did say at one point that he wanted Ethereum to always be able to run on a single laptop, right? So, but I think he's gotten a little more mature over the years and has, faced the music in terms with some of these challenges. But that's why people like Randy exist, to like help make things function at scale, right? And I'm looking forward to what you have to share with us. So thank you, Randy. Give him a hand.
Yeah, thanks. Is microphone working okay? Hopefully. All right. Yeah, so I'm Randy Harrison. I'm VP of Platform Engineering at Blockdaemon. And I'll talk more about us at the end if anybody's interested. We basically are a node infrastructure provider. We provide APIs, different layers. We run managed nodes. We run bare metal for folks that want to build their infrastructure on our infrastructure. So what I'm going to talk about today is an introduction to the Saga Pattern. Has anybody heard of the Saga Pattern? Oh, great. That's good news. And using Temporal as a workflow engine, and what the case was for doing that, why we used it, and what our benefits so far have been. I didn't really know whether to aim this as a super technical presentation or as kind of more an intro and make a case, so I tried to shoot a little bit in the middle, but keeping it high level enough, just so no one got lost. So for those of you that are looking for more of a how-to guide, I'm sorry about that. Maybe I'll get to come back and do that later. Yeah, so I just described what we're going to do. We're going to talk through microservice architectures. Let me ask, I'm sure everyone here uses microservice architectures. And is anyone struggling with scaling those at all? Yeah, potentially. Yeah, so that's what we're going to talk about. We ran into that a lot. I have the benefit of also having gone through a very similar transformation at Coinbase. A lot of what we did is very different architecture internally because it's a centralized exchange built on Ruby on Rails initially. A lot of people don't know that. And so upgrading that and changing the underlying architecture while not disrupting any business services was really the larger challenge at Coinbase. So again, this is an introduction, not a tutorial. So the pattern that we usually use for scaling services is database per domain. That's something that Amazon recommends in AWS for scaling out. And that's an assumption that each service or each domain of services, kind of group of services, has its own database. And then you're also assuming that the business transactions do not span across those different domains, which, of course, in reality, they often do. And that's primarily what we're going to talk about. So the Saga pattern is It's a fairly new pattern that is being adopted by a lot of different companies, and that's an attempt to use either an orchestration or choreography-based approach to resolving the problem. So I'll try to describe what I'm talking about. So the super idealized version of services, microservices, when everyone learns about it, is super easy, very abstract. And that works really well when you truly have microservices that are serving a single function that can be purely encapsulated, and you can have an ACID transaction to phase commit at that level. In reality, we end up with lots of different domains that have to cooperate together, and what effectively is the logical business transaction spanning those domains. And then we get into how to solve that problem, because we can't have an ACID transaction across this kind of an architecture. We can't do two-phase commit. So usual approach is to either create a monolithic orchestrator. This is when I first came into Coinbase, what we were working with, which was a very cool custom, internally created orchestration layer, lots of custom queuing, leveraging some other frameworks and such. A lot of folks these days will look to this sort of an approach, which doesn't make sense when you're just, it doesn't make sense beyond just a few service domains. And what usually folks will do is introduce some kind of an event bus in there. And Kafka's the choice these days. If you go back to when I was at Coinbase, it was more RabbitMQ, that kind of stuff. So you end up with all these queues and all these listeners and pushing and pulling in between all the different service domains. And it would be nice if we could have a layer that managed state for us. So the Saga pattern is it's a way to manage the data and the consistency across it all, basically. And the idea is that you treat the transactions as a story, a sequence of steps across all of the points, and then you remit all of those messages to some kind of a workflow layer. And the workflow layer will maintain state, it'll maintain the state machine, it'll manage persistence across those. And as you'll see in a little bit with a solution like Temporal, it allows you to horizontally scale very easily with sharding. So the super simple way to look at the Saga pattern, and I included a few links to some of the work that folks have done on the more academic side of the pattern, is that you treat each single microservice as a node in the Saga, and you ensure that within each service box, that is a fully committed ACID transaction. So that's an important factor, that you can have ACID transactions kind of at that atomic level. And there's two approaches to implementing a Saga pattern. One of the more elegant ways is the choreography approach. That's very similar to what a lot of us have either inherited or maybe still working on maintaining, with wiring things together with Kafka and RabbitMQ and all the different queuing. So this is pretty simple and straightforward, where it's an idealized version of an order service and a customer service. You're assuming that the customer wants to place an order, and the consumer or the customer service is checking their credit, determining if they have the credit. So again, a very simple example. It's emitting its events to the message bus, which is what we all tried to create with Kafka when we went through this, kind of manually ourselves. And then, this guy on this side listens and picks it up. It still doesn't solve for what happens if I need to roll back. That still has to all be custom. You have to figure out how you reverse the transaction. And defining that can get fairly messy. The orchestration approach, which also is possible in Saga, is basically creating a message broker in the center that manages those queues for you. And so this is probably very similar to what a lot of you that have had to deal with this challenge have sort of built on your own anyway, or have assembled together with all the different normal tools and facilities that folks use. Folks have tried to do everything from build out completely using Kubernetes to building it all just straight in code. So the workflow engine is the piece that we'd like to have do all that hard work of maintaining the state machine for us and the message bus and all of that stuff. And in addition to that, we'd like to have, to all the queuing and everything, we'd like to have timers, we'd like to be able to create, agents and daemons, if you will, so that those can run on schedule. We'd like to be able to implement all that and still keep separation of concerns and not couple any of our business logic. And the properties of a workflow are pretty simple. And because you ask, what is a workflow? And a workflow engine executes workflows, and a workflow is very simple. It's kind of similar to the definition of a service, but we don't use the same language because the service is really the API that's outward facing, and the workflow is the thing behind that that's actually implementing the logic, the business logic. And it has to be able to execute tasks within some kind of a resilient program and then react to both internal and external events and timers. So does it time out? Does it have to retry? That kind of stuff. And that's very important specifically in blockchain applications because there's pretty much never a guarantee of execution. And so you often have to get into a situation where you're monitoring, you're checking block heights, you're doing all this kind of stuff behind the scenes and polling it or whatever you're doing so that you can continue or try to reverse some transaction that you're trying to commit. So if we think of workflow as a state machine, you can really think of it as you've got to define some kind of a workflow function and define tasks within within that workflow function and have some kind of engine that executes those. So it may look familiar. It's the command pattern, which was pretty popular, like early 90s, Gamma et al. For anybody that remembers that stuff. But really, this is just that implemented in a infrastructure layer by a workflow engine. And if we then add task queues, timers, those sorts of things, that's also what we want the workflow engine to manage for us. And we want to be able to assume that each activity box itself is a durable ACID transaction. And if we can assume that, then we can look at this whole view where we have a workflow defined of multiple tasks. Each of those tasks is its own ACID transaction. And any reversing that we need to do on a failure case can be part of that business logic itself. And that's an important aspect to thinking differently when you're implementing workflows as opposed to kind of monolithic service layers or a monolithic broker in between microservices, is that you want to keep a encapsulation of the business function altogether, whether that's forwarding and committing a transaction logically or whether that's reversing that transaction if there's any point of failure. And again, that's very important in blockchain applications because often undoing or reversing a transaction doesn't mean what it means kind of in the old school world or the cloud world. There's many things you can't undo, obviously. So it really is a reversing transaction. It could be crediting something that was debited on a ledger or whatever it might be. If you're depositing funds to a deposit contract as an example, and then you want to reverse off of that because it failed and it didn't go all the way through, you can credit that back off, that same contract. And I'll show you a glimpse into that as to the real world application that we have at Blockdaemon. So Temporal is one of the more hot workflow engines right now. It's getting a lot of kind of attention. It's fairly new. It grew out. It's fairly new in terms of being called Temporal. It's an old project. It was started at Uber. You can read the history. It's kind of interesting. It was called Cadence at the time. It's an open source framework. Temporal is still open source, but they formed a company around it primarily so they can provide service and then a cloud if you want to run your workflow clusters on their cloud. The creators left, like I mentioned, they left Temporal. So who has adopted Temporal so far? There's a list of some of the companies. I mentioned Coinbase, where I was earlier. It's very kind of interesting implementation there in conjunction with the Odin project. If you're familiar with that, it's an orchestration open source project. And then most recently us, Blockdaemon. That's what we're in the middle of now. So I went back all the way to the Cadence documents for a good, simple picture. You can't find good, simple pictures of temporal. If you go to try to look it up, you're going to find lots of code, which is cool if you like to know how to actually do it. And you're going to find some pictures that aren't really all that helpful if you're trying to get this kind of like big view. What even is this? What's the overall architecture? So I went back to the Cadence documentation where they represent it. Now, a little bit of this has changed. So Cassandra is not often the choice as the underlying database layer these days. It can be still, that's fine. But you could think of the workflow engine architecture as implemented by Cadence/Temporal as you have some front-end application. It's doing its calls and its things to the workflow engine. And inside the workflow engine, it's managing a matching service, something that so it can find all of the individual execution threads of the tasks that it's managing, and a history service so it can determine what's been run, what's the current state of it. And then it syncs all of that persistence into its persistence layer. So that's everything from storing the definitions of the workflows and the tasks to the actual events that are being emitted. And most importantly, to some folks, is a visibility layer so that you always have a view into the current execution state of the state machines. If you want to see what's kind of inside how the front end calls, and it's pretty interesting if you really want to get kind of geeky about how temporal works under the hood. It uses a hashing mechanism where it generates a unique hash for each activity that it executes on a workflow, and each workflow has its own hash. Those hashes can help the overall workflow engine and orchestrator identify where they're at and which ones match the others and which ones don't match the others. It also solves for the big problem, which other workflow engines have not solved as well, in my opinion, which is versioning. Because what happens if you start fundamentally changing some of the workflows, but you have long-dated timers, like year-long timers. Some companies, Coinbase had timers that were a month long in many cases. So you have this issue of basically maintaining the versions. And this mechanism really helps that quite a bit. And inside the history service, if you want to see kind of what's going on there, it's maintaining a workflow state, like I mentioned. It's able to shard across. There's the timers and the queues and some kind of a controller layer that's managing where all those shards are. And I'll talk a little bit about how sharding works. It's kind of its own subject in and of itself in temporal cluster configuration, but I'll touch on that briefly very soon. I'm going to pause here for a second because I've been kind of racing through this and see if anybody has any kind of questions, wants to go back and kind of dig into one of the topics I've covered so far a little bit more. All right. Yep, go ahead.
You mentioned it's kind of like doing it yourself on Kubernetes with event queues and stuff.
Yep.
How is that? What makes it easier with temporal?
Yeah, the primary thing is that when you try to do it yourself, you're ending up managing the state across, especially when you start scaling out horizontally. And so the biggest problem, at least that we ran into trying to build our own solutions, was having that state be synchronized across all of the shards. And we were spending a significant amount of our effort on the database layer, making sure that all those databases were constantly synchronized and avoiding race conditions. And the other problem that often will impact doing it yourself with a, say, Kafka and Kubernetes kind of solution is you have to really, by convention, enforce transaction encapsulation to prevent race conditions. Because if you end up with a failed transaction in one of the services that's part of the Saga, it'll just race and hang, whatever's depending on it, whatever's coming next, however the sequencing or the logic works. And what the workflow engine is doing is it's forcing that transaction encapsulation, and it's managing the synchronization of the state across all the different shards. Yep.
So a lot of these problems sound very similar to what is solved by like the AWS step functions. How does temporal compare? Like, is there any benefit over using AWS step functions as opposed to computing temporal anywhere except AWS?
Yeah, so I actually have that on a slide coming up in a couple seconds. AWS step functions and lambdas are a very popular way to solve this. The biggest thing there, and just to jump to the conclusion for us, is we're multi-cloud. We can't be fixed to any one cloud because a big part of our value proposition is decentralization. Very few companies want to run their nodes and they're all pinned to Amazon West or whatever. They'd like to have that distributed a little bit more. It also prevents lock-in. There are some more technical arguments people get into, but I don't want to get into that because I'm not an AWS like solution level architect myself. And you could do some great things if you're fully sunk into and invested in that ecosystem. Yeah, you had a follow-up?
I was just curious if you know how they're syncing the state under the hood, like etcd like.
Yeah, so
Or?
I don't know all of the details about how they do that, but I can show you some good documentation that it's pretty complicated.
Yeah, it's a fun problem for sure.
Yeah, so I thought, just in case, because people always like to see code, showing a little bit of code. This is just the Golang hello world and how you approach that. First thing people do when they pull open Temporal or download it and load it on their local development environment. There's really three pieces you need to define a workflow. You define the workflow itself, so this is the thing that hosts the activities and it calls the activities. It does the logging. And it's effectively the controller for the activities, and that is the workflow definition. The activities themselves are super short. Usually you keep them as short as possible. In this case, it's just emitting a hello world as a string to the content, and the context was passed to it. The context is held by the workflow. The activity comes back. Those could be threaded or initiated, to any degree possible. And then there's a front end somehow, something that launches it. This is just a Golang example. I think Temporal supports 4 languages right now: Java, Golang, TypeScript, and probably Python. I can't remember the other one. There are some other workflow engines that support dozen or so languages. I'd like to see Temporal support Rust myself, but that's my own bias. Here's the alternatives we explored. I mentioned those. So we've already talked about the kind of doing it yourself approach. Another interesting approach, and what we actually were using in a slightly different context at Coinbase, was Airflow and DAGs. There's a challenge to using DAGs as a workflow layer, which I think I have a slide about later, but I'll bring it up if I don't. We also looked at Zeba or Zeba, or however you pronounce it. The challenge with Zeba is it's not really a programmatic workflow approach. It's more of a business model definition sort of approach. It's BPMN compliant. It's pretty popular with kind of more like pure IT groups that are solving lots of internal business problems. It's a little less popular with product developers that are maintaining some kind of a product suite or something like that, or some kind of infrastructure layer. And then, of course, there's AWS step functions and using those to orchestrate Lambda functions. And that's a perfectly fine approach, again, if you're really invested in the Amazon ecosystem and are okay, just making that your lingua franca or whatever for everything. I think there's an equivalent in GCP as well. GCP is always a little more difficult to understand because it's Google. But yeah, and I noticed there that Zeba is not programmatic. So I'll stop there before I show a few examples of kind of how we've actually implemented what we're using it for. Is there anything anyone wants to challenge, talk about more? Say this is ridiculous. Why would you even have a workflow layer? Nope. All right, so we have a few applications of it. I thought I would talk about the blockchain orchestration service that we're in the process of internally betaing right now. So to just describe what the service is intended to do at a super high level, is it's a way to tie end clients together through to custodians without the intermediary having to be a custodian themselves. So there's some pretty complex key sharding, MPC kind of stuff, multi-party computing that's hidden in the back end. And there's different approaches to batching the transactions. As you know, the kind of brute force way that you would solve this problem is you would just get whatever batch of transactions the customer wants to, or the client wants to sign or wants to commit, and you match those with the keys, pass them back. They've got to sign them. They have to click a million times if there's a million transactions, or they got to write a script to do it, or whatever it is. That gets pretty ugly, or the people go to Wallet Connect and they manage it at the wallet level. All of that. What we're doing is we're trying to bring this into a simpler, kind of more easy to access programmatic solution. And the concept at a super high level, as I just described, is, and I've just represented part of it here in this C4 diagram, is a batch deposit. So you got this concept of getting the keys, basically what I just described. I probably should have shown this picture when I was describing it. Sometimes I forget why I made the pictures and I just keep talking. Real example, going in a little deeper. So starting kind of at the top, we have our boss server in the middle. That's the thing doing what I talked about. We have our systems in the background here that do the other stuff I was talking about, like key sharding and managing all our internals that keep track and logging and stuff. And then we have the cluster down there. Okay, so the temporal cluster is that magic box that we call those workflows from, and it scales them as necessary. It self-heals as it needs to, and passes back the states. And to show kind of what the infrastructure looks like at a super high level, and this is again why we are not using Lambda functions to solve this, is we actually are using GCP as our controller cloud, and then our intercloud router off of GCP, where we either scale out or access the nodes that we run on AWS primarily, and then some that are bare metal that we run in TerraSwitch, I think. And that's super high level. Within the temporal cluster itself, this is very similar to what I showed from the original Cadence pictures. Is temporal's got its front end interface, the Golang API. It's got its matching engine running, a history engine that it's running all the time, a persistence engine that's running all the time. And then there's the worker. And the worker is the interesting part because that's where our code is that's doing its stuff. And to see where those workers actually end up in the overall architecture, you can see kind of out front here, we've got our public-facing APIs, register, generate, stake, withdraw kind of APIs. And the workers, we have a notification worker, a staking worker, and a temporal cluster. The temporal cluster is running that state machine. So it's managing the persistence and synchronizing the data and determining the state of all of those workers that are working. And the workers themselves, in our case, we're running just directly on our cloud infrastructure. There are a couple of different approaches to implementing this. We're experimenting with running everything in one cloud kind of infrastructure, with distributing across cloud infrastructures, with running internally or running on-prem or running externally. So it is pretty flexible in that regard, but you kind of get hopefully you get the idea that basically it's farming out to the workflow layer the concerns of managing all of the synchronization at state. And here's the results so far from our testing, just our internal testing. What you can see here is, and this is what I was talking about with configuration, it shows both the performance advantage of temporal and some of the challenges that you can get into. And there's different challenges with other workflow engines as well. How you set it up is really kind of important. And this can be a real mess if you set it up wrong. Because basically when you define a cluster and deploy a cluster, you have to set the static number of shards that cluster is going to maintain, and you can't change that later. So you got to retire that cluster and deploy a new cluster if you determine that you either have too many or too few shards, which you can have both. What you're trying to do is to match your performance latency with your database latency, get those as close together as possible. If you have too few shards, you end up with a diminishing return, and if you end up with too many shards, you end up with the other end of a diminishing return. So you can get into trouble either way. They do have a temporal cloud, which we are just now, we signed a agreement with Temporal to trial that for 6 months. It's not publicly available yet, but they're obviously working with companies. If you have a reasonable use case and they're kind of determined that their infrastructure is prepared to run it, what it does is it manages all the cluster stuff for you. That's basically what they're doing. And when I mentioned and showed in that last picture the different pieces, that's what's important is we're running this piece down here in the temporal cloud, whereas we're running these on our cloud. So the workers themselves are running on our cloud, and the temporal cloud's managing the state of those, and invokes those and cleans them up when they die or whatever it is, all that kind of stuff. Let's see. So, I also wanted to mention that if you go looking for temporal cloud, there's a company called Temporal.cloud, and that's not Temporal Cloud, which is unfortunate. But it's cool. It's an IPFS cloud, so no knocks on them. And so here's the kind of overall top level of the benefits that we have realized. A big thing that's making our security folks and our ISO folks happy is being able to have role-based access and be able to enforce that in a more templatized manner that's more standard instead of kind of custom trying to enforce it at in every domain layer. And improves visibility is a big part as well. And that was a big problem we had at Coinbase with the custom orchestration layer, was the visibility was only as good as we wrote code to see the visibility. And so that became a challenge after time, and there was always people arguing it wasn't really accurate and all that kind of stuff. So consistency was a big challenge there. Our developers really like it. I put it as the last point down there, the addictive quality of it. It's interesting because as developers try this out, at first it's an extra layer, it's a waste of their time. Why am I messing around with this? Defining even more little pieces of code that are going to sit somewhere else, and having even more GitLab repos that are managing all these workflows. But it does become pretty addictive for them once they kind of get into it. At least that's what we found. And then we have the opposite problem where they want to use it for everything. So we've got now folks on our infrastructure team that are wanting to create workflows for their, Ansible stuff and that kind of thing. And I'm not sure that's a great application for it. There's no reason you couldn't, but it is kind of addictive in that way. And then the other advantage of scalability, and scalability is going to be different based upon whether you choose to try to implement Temporal completely self-hosted on your own cloud, or bare metal, or whether you're using their cloud. And we found it was difficult to scale ourselves. We have a really good team of infrastructure and DevOps and all the folks internally. They really know their stuff, in my opinion. But it was still fairly complex when we were doing our kind of load testing. And I think that's kind of the overall intro and view that I had kind of prepared. Blockdaemon, just a couple words about us. So if you're not familiar with us, I encourage you to look us up. We provide basically node infrastructure. We have APIs that sit on top of that infrastructure. We have a product called Ubiquity, which is ubiquitous access to managing nodes to make that a more unified experience for those who are trying to manage nodes. We have a lot of institutional customers that are running Ethereum nodes and staking ETH2 nodes, that kind of stuff. We also run oracles for a few of the networks. We have about 50 protocols. Probably should go to the next slide where I put this on here. We have about 50 networks that we're currently managing. We recently just rolled out our NFT API. An NFT marketplace is coming soon. I mentioned the blockchain orchestration, signing services, liquid staking. Like everyone else in the world, we're frantically working on liquid staking products because that's all everyone's about these days, the people with the big budgets. And then overall, like a block daemon marketplace. And that's kind of similar in different ways to what a couple of exchanges have created. Coinbase has Coinbase Marketplace, if you're familiar with Coinbase Cloud. I think Figment has a marketplace. And so we're looking to leapfrog them with a market like everyone's trying to leapfrog everyone all the time. But yeah, that's basically what I had prepared. My apologies if it wasn't super programmatic. If those of you who wanted to get in and kind of see how it actually runs under the hood, I wasn't exactly sure what to shoot at, like I mentioned before. But kind of looking across the crowd, I definitely would have some demo and code and to look at next time around if we were to go into this deeper. We're at the beginning of our journey with Temporal, as you could probably tell. Not so much with solving this problem. It's been a long-running problem. It's a problem I had the luxury of inheriting when I came in. And we're resolving it, like I mentioned, just to summarize, with the Saga architecture. And our assumptions right now are that we're going to be able to use a workflow layer to manage the complexities of that for us. So I'll open it up to questions or comments, or if anyone's using a whole different approach that we'd want to compare something like this to, aside from Amazon Lambdas, which everybody kind of knows about. Or anything else you guys wanted to try to dig into a little deeper? Yep.
Can you remind me what the workflow example was? Or do you have like a more concrete example to help my mental model of what you're talking about?
Yeah, I didn't have anything prepared. The concrete example of our block signing service from what I showed. And what we're doing right now, to talk about that a little more, is we're trying two different approaches. One is the send a batch of unsigned transactions back to the client that they sign and send back, and then we commit those to the blockchain on their behalf. So the kind of basic stuff at that level.
Like a queue and do the jobs. Okay,
exactly.
Like a rabbit and queue, but at scale.
At scale, yeah.
Okay.
We're also working on an alternative approach, which is using a deposit contract to do that, so that the client end only needs to sign once. And that's the ultimate goal. If you're familiar with EIP 712, I think it is, meta transactions, it's got similarities to that, although that's more permissioning and kind of permit functions sort of stuff. I'm not sure if there's I'm not an Ethereum expert, so I'm not sure if there's other EIPs that are very specific to the problem we're trying to solve. But I think it's the 712 and 713 kind of, I don't know, those EIPs. Right now we're just using ERC20, straightforward approach like everyone else is. We're also trying to create this in a way that it works across the other protocols. So if you're familiar with Solana, it's a whole different animal. And our goal is to have it be the same, from the outward API, public API standpoint, and hide all that complexity in the background. And that's another advantage of a workflow engine, is we can basically fan out all the different protocols and have the workflow engine managing, all that matching and where does it go, which workflow does it invoke, and that kind of thing. Yep.
You said Coinbase was using this as well. Do you have any examples of what Coinbase is using Temporal to manage? Yeah,
they're using Temporal, and it's not even done yet. Although I've been there for a little while, about 4 months. So maybe they finished it suddenly, but they were taking a really slow roll. It's the core exchange, and it's primarily customer like debit credit actions on the exchange. And what Coinbase has kind of internally is this concept of a life book of records and an accounting book of records, because they have so many users that are scaled across so many shards or whatever. horizontally, all that data constantly streams into this super high performant, write-only live book of records. And then there's a consolidator that is constantly running, pulling that out into consolidated accounting book of records, which some of that is real accounting and it goes to finance because it's an exchange and there's all kinds of rules Coinbase has to follow, highly regulated is how they account for that. And then other stuff that's like more BI, analytics, that sort of stuff. And that's really where most of the temporal work has been, is in remitting all of that kind of streaming scale to a workflow layer.
So if I understood right, if you want to spin up a temporal cluster with a different amount of shards, you have to shut down the previous one and spin up a new one. What is like the latency and process of shutting down one cluster and spinning up a new cluster? Is that a time-consuming process, or is it something that you do pretty quickly? Or
We haven't found anything to be super quick, to be honest. I can't say how much of that is just us having not automated a lot of that yet. It is all automatable. So, with enough time, we tend to follow the philosophy of not automating first. A lot of folks jump right to automation. One of the philosophies I have is make people go through the manual process enough times that they optimize that process and then automate that. Yeah. So I'll be very honest. It's a fairly heavyweight process. At least we found so far configuring. Sometimes you got to do a little math, that kind of thing. Anything else? Cool. Well, I invite you guys to check out Blockdaemon, and we're also hiring. So those of you who are engineers, we're always hiring engineers, marketing people, salespeople, biz dev, all that kind of good stuff. And we're global. We're all over the world. So less so in Asia, but we're growing rapidly in Asia now as some of the markets kind of figure out their regulations.
Thanks a lot for coming, Randy.
Yeah.
Thanks for watching for lunch. There's still a lot of food back here, guys. Still want some more. I can't lose weight.